All right, when it comes down to module 10.1, this is again all potential questions that could be on the final. So it's imperative that you understand how systems of equations work. So the way these problems are is in fact a system of equations. All right. 4475, by the way, Sarah. All right. So when I'm going ahead and doing this, all right, it says a particular movie theater charges $8 per ticket for adult ticket and $4.50 per child ticket. Suppose that 550 people attend a movie and total revenue for tickets is 3,875. Write two linear equations to represent the system of equations where x represents the number of adult tickets and y represents the children's tickets. So we know the fact that there were 550 people who came to this. So the children and the adults, all right, or adults and children, this will be the adults and this will be the children, were a total of 550 people. We know that by what was given to us. We also know that the adult ticket was $8 per ticket and the child's ticket was $4.50. So what you do is you take and multiply 8 times x, because that's the adult ticket, the number of adults who came were here, so at $8 a piece, and then the children's tickets were $4.50 per child, and that is equal to the total revenue of $3,875. So if we were to multiply this out and add them together, right, then we would get our total revenue. So this works for that. All right. Now the thing is, this is a system of equations. All right. And the best way to handle these kinds are through substitution. So we go ahead and bring the x over, make it become that. And then we substitute y equals 450 minus x. So this is what y now equals. So we're going to go ahead and take that y and replace it for all of that. So we're going to have 8x plus 450. And I'm just going to drop the 0. I don't need the 0. And then it's 550 minus x equals 3,875. All right. Now, this becomes nothing more than a calculator thing. Okay. So what you do is you go ahead and do the distributive property. So just grab your calculators and multiply it out. So 4.5. All right, so 4.5 times 550 equals 2475. And then 450 times negative x is negative 4.5 x equals 3,875. Now we're going to go ahead and just subtract this from this and subtract that from that. So take the 3,875 minus the 2475. That's kind of easy. You get 1,400. And then go ahead and take 4 away from 8 is 4, and then take another 50 is 350. And now take the 1,400 and divide it by 3.5. And so x equals 400. Now, since x equals 400, and we know that 400 plus y equals 550, we subtract 400 from 550 and get 150, right? So the y value, or the number of children, is 150. So we have 400 adults, 150 children. All right. So that's what we get for that. Okay. So number one, okay, so I don't know which one's one? Okay, one is writing two linear equations. So this is the two linear equations that we did. All right, and then of course um, it's either or. Okay, so they didn't even ask us to solve for it. Darn it, I didn't even ask. I didn't even do not solve. How about that? I mean, I didn't even read the instructions. But you know what? This is paramount for you to get elevated into solving it. So I went over and beyond. So it supports you in going forward. But yeah, Brian, it is what it is. But you know what? I'm glad to go ahead and support you in getting to solve it. So it's good practice. So here are the two answers that we have. Okay. So yeah, it's important that you learn how to solve it though. I mean, it is important. So I don't mind going the extra mile. So I went over and beyond. So I did it, and there is the answers that you would have. Okay. So let's go ahead and continue. Okay. Now it says for question number 2, well, now let me go ahead and make sure I'm reading it all. All right. It says find two numbers. Okay, so now I got to actually find the two numbers in this one. Okay, I finally read the instructions all the way. I need to solve it. Okay, so for question number 2, we're going to go ahead and say that find two numbers A and B whose sum, so we have the sum is equal to -1, and whose difference is equal to 3. All right. So we have now two systems of equations. So we can go ahead and do it by any method. We're going to do elimination method right now because it's just set up so easily because the b's are just going to knock each other out when we add it together. So we're going to get 2a equals and then 2. So a equals 1. That was so easy to find. And then we go ahead and plug that into here or here, however you like to go ahead and do it. All right. But we can plug it into here. And we have 1 plus b equals -1. So we're going to subtract 1 from both sides, right, to get b by itself. And we get -2. So that's our answer we get. So a is 1 and b is -2. All right. So it's good practice, even though I busted my hump doing something I didn't need. This was good practice in order to make these kind of questions even easier, huh? All right. Now, number 3. It says a boat traveling upstream for 36 miles travels upstream for 36 miles for 4 hours and returns in 3 hours. So we have two acting forces that is being applied to the boat, and that is the stream's current, the stream's current, and then the boat itself. So if the boat was running, what is its speed without any current? And then what is the speed of the current? So that's the two things that we're trying to find. So we've got to realize is that this boat is being acted upon by forces, but distance equals rate times time. We do know that based off of basic science. Okay. All right, now distance equals rate times time. So we have again 36 miles, and it's same distance going there and coming back. So the thing is that we have these two forces, right? Where is the rate? It's the time is changing based off of this right here, okay? But we have the time it takes for it to go upstream, okay, is 4 hours. So time is that, but we have two different rates going on here. We have the boat's speed along with the current speed, and it's upstream, so it takes longer. So it's going to subtract from the speed of the boat, right? So the current is going to subtract from the boat's speed because there's two acting forces that are being impacted by the rate. All right, there's the boat speed and the current. Now it takes 3 hours to get there or to get return because it's going downstream. So we have boat speed plus current is equal to still the 36 miles. So I think that is what is most important for you to understand and for you to process is the formula, and as well as understanding how the current works in this one. And when you're dealing with airplanes, it's going to be the wind speed, right? So however you like to label these, but you want to go ahead and label this with some kind of a determinant for boat. And see, that's why I put it as B, because it says the rate of the boat. So you can go ahead and say rate of boat, and you can finish this out. Rate of the boat, all right, and then rate of the current, right? So you can say rate, and you can put of the current. So it's important to understand what these letters represent. But now the process then doesn't change from anything else we've been doing. What I'm going to do is go ahead and take this and divide both sides by 4 so I can get this isolated. And then I'm going to divide both sides by 3 on this one so I can get it to be this. So now I have 2 simple problems, right? A lot easier than if I was to do the distributive property and such. We want to be very, cognitive of that opportunity if we can divide both these out so we don't have to deal with the distributive property. Because now we're back to what we did in the other problem. So we're going to go ahead and just add these 2 together because the currents will knock each other out. And then we're left with 2b equals, and then we just add these 2 together. All right, and adding those 2 together, we get what, 21? All right, and now we divide it both sides, and we get the boat speed is 10.5 miles per hour. All right, so the boat speed in still water is 10.5 miles per hour. Now, in order to find the rate of the current, we can go ahead and go into any one of these 2 problems and just back substitute it in. Now, I'm going to go ahead and use these formulas, right? I don't need to use these formulas. I can go back into here, and I can just type it into this one, all right? Putting it into this one, I'm simply going to subtract from the current, from the 12, and get what, 1.5? And that's miles per hour. So we have our boat speed and our current speed, the current being the current of the water. All right, so that is how we approach these types of problems. They're pretty straightforward, in my opinion, once you understand the setup. Because now it says a man flies a small plane from Fargo to Bismarck, North Dakota, a distance of 180 miles. So we're dealing with this current speed thing again. Like, because he is flying into headwind, the trip takes him 2 hours. On the way back, the wind is still blowing at the same speed. How fortunate is that, right, for this situation? So the return trip takes only 1 hour and 12 minutes. What is his speed in still air? And how fast is the wind blowing? Okay. Now, when we are looking at this, okay, we're looking at figuring out the setup, and the setup is very much like this one. These 2 being back to back were pretty convenient that they were, okay? Because now we're going to go ahead and we got the distance equals rate times time, and we got the same distance going there and coming back. So it's going to still be 180. So we're going to do our setup. So we're going to do 180, all right, for both there and returning. And now we're going to go ahead and set it up. So it takes 2 hours. So we're going to do 2 times, and then we have the speed of the plane. So we're going to say plane P plus wind speed, and we're just going to put W. It's headwind. That's minus. Okay, so we're going to put plane minus win times 2 equals 180, because we're following, again, distance equals rate times time. Okay. Now here's the next tricky part, is that it says 1 hour and 12 minutes. Now we can't put 1.12. Now the reason why is because that's not how you express 12 minutes as being part of the hour, because there's only 60 minutes in an hour. There's not 100 minutes in an hour. If it was 100 minutes, yes, we would be fine. But what we're going to do is take 12 divided by 60 in order to turn that into a decimal of 0.2. So we get 1.2 times the plane speed plus the wind speed equals 180. That one, I almost assure you that 99.9% of the students would put 1.12 and get it wrong. Okay. So be careful with that. That is a breaker for many, many students. So now we would go ahead and do the same thing we did before, where we divide it out. So we take 2, divide it into that, and we get this. And let's see. All right. Now, going ahead and doing what we did up here. I love how this works out with these problems. That all we're doing is knocking this out. And then adding these two together, we get 240. And then plane speed is 120. So the plane speed is 120. We can come back into one of these two equations. It doesn't matter which one we come into. All right. If we go ahead and plug it into here, we would subtract 120 from this and get 30 miles per hour. So the wind speed, I do it mentally because I can do it mentally. I'm hoping if you can't, you can try to, by simply putting it in here and subtracting it from 150. So now we have our two values, plane speed, which is the 120, and then the wind speed is 30. Okay. So we have our answers now. I'm so glad to be able to help you with understanding how to change minutes into a decimal, because it's take the value of whatever number of minutes they give you and divide it by 60. Okay. That's your base for time, not 100. All right. Now, continuing. You're choosing between two different cell phone plans. The first plan charges at a rate of 22 cents per minute. The second plan charges a monthly fee of $49.95 plus 8 cents per minute. How many minutes would you have to use in a month in order for the second plan to be preferable? I said plane, but plan, excuse me. All right, now it's 22 cents per minute. So that's 0.22 per minute. And we're trying to see when will it be a better deal if we take and give them $50 basically. Excuse me. So it's $49.95 plus the 8 cents. So that's 0.08 a minute. All right. So that's basically we're going to see is when will the minutes, or when will these be equal? So that's what we're looking for. And if we're looking at it, when will this be greater than this, basically? And when will it be better? But I mean, we're not going to get into that level of detail. We're just going to go ahead and just solve this. That's all we're going to do. So we're going to take, and we can use our calculators. We could just take 0.22 real quick, subtract 0.85 or 0.8, excuse me, 0.08. And then you get 0.14, and then you divide 49.95 divided by the 0.14. Okay, now just double checking that I put all my math in right, and it looks like I did. So now round to your nearest whole number. So the rounding the minutes is equal to this ridiculous number. That might be a little hard to see, sorry. It's 356, 78, and all that stuff. So I'm going to go ahead and put 357. So after 370 or after 357 minutes, all right, it's going to be where this plan, okay, is better than this plan. Although you put down, you put in 49.90 or 95 for the beginning of the month, and you get charged a lot less per minute. And if you're using up your phone a lot, then obviously the 357 is a lot better. Okay. So excuse me, not 357. This deal is better. So that takes only that many minutes to get that level. All right, now number 6. All right. Here we have when hired at a new job selling jewelry, you are given 2 pay options. Option 1 is base salary at $17,000 a year with a commission of 10% of your sales. Base salary is $25,000 a year with a commission sale of 4% for sales. Okay. In order for option A to produce a larger income, you would need to sell blank, at least blank of jewelry each year. Okay. Now, again, you're getting paid less a year, but you're getting a higher percentage for the commission. So that's significant. Okay. So what we want to do is almost like what we did in this problem right here. And again, these are kind of next to each other for a good reason. We have 0.1 times the sales, we'll just say X, the amount of sales, plus 17,000. And we're going to go ahead and set that equal to the 4% or 0.04 times X. Okay. And then plus 25,000. If you stink at sales, like just you're just not good at selling things, you might want to have a higher salary. So what you do, and this is, I'm all doing this on the calculator, you're going to get 0.06 and then all that stuff. And then you subtract 17,000. And all this can be just done quickly on your calculator without having to write anything. So all you got to do is put, 25,000 minus the 17,000. And then you get 8,000 divided by 0.6. And then you get that. So, and it says it wants us to round, right? Well, it's going to want us to round, but because what you end up doing is that, right? So you just go ahead and plug it in your calculator, right? So you get this number and you get $133,333.33 worth of jewelry. Let's go ahead. That's quite a bit of sales. I personally do not like selling stuff myself, and I would find that to be ridiculously, a lot of money to have to sell. But you're talking about jewelry, so jewelry is, yeah, Ryan, I'm horrible at sales. I guess because I don't like to think that I have to tell somebody that this product is everything that they're dreamed about, because no such product is. It's like you're an impulsive buyer a lot of times when you're buying things. So I'm terrible at it. I would be like, just be honest. Like, do you really need this? So this is that. Okay, just so you know. Now, question number 7. All right. It says the admission fee at a amusement park is $1.50 for children and $4 for adults. I feel like we're doing the theater thing, the movie theater thing again. All right, where it says on a certain day, 315 people entered the park, and the admissions fee collected was a total of $760. How many children and how many adults were admitted? So it was like that one that we did with the children that they actually didn't want us to solve, but I did anyway. So this was a prelude to what we were looking for. And that, so this one's going to be the same way. So all we're going to do is we know that children and adults entered into the amusement park, and it's going to be 315 people collectively. Now we know that the children, okay, where I'm just going to let x equal children. So I'm just going to put, once I associate the $1.50 with x, immediately I'm saying that x is the children because of that reason. And then I associate the 4 with the y. That means y then becomes the adults because I've declared that by saying that 4 is with the y. That's how I declared it. It does. I mean, now some people put C for children and then A for adults. You can use whatever letters you want. It doesn't make a difference. Now, the collective amount is $760. All right, now I have this. I go ahead and bring this over to the other side, make it become negative x, and then I have y equals this. Now I'm going to go ahead and plug that in for here. And then I'm going to do the distributive property, combine like terms, and do all things required for isolation of x. So I'm going to go ahead and do some valuation here. So 4 times 315 gives 1260. Subtract 1260 from 760. All right. So I'm plugging in all my calculator because I do it where it's so easy. All I do is I get this value. All I did was multiply this times this, subtract it from this, multiply this times this, add it to that, and then I'm going to go ahead and get some value. So it's 4 minus 1.5 or 2.5, right? So you get 2.5. I mean, I don't care about doing anything in my head. I just want to go ahead and plug it all in my calculator. So I just do it real quick on my calculator because I'm doing all this and it's like, why do I need to write all this stuff down? Many of you make so many mistakes when you're doing, even I do. So it makes no sense. Sometimes our brains have, it shuts down because you're doing too much math in your head. So you just allow the calculator to do some of it for you, right? So we have x equals 200. Now, once I go ahead and find x equals 200, we're going to go ahead and come back into the equation up here and subtract 200 from 315 and get 115. So that means that I, looking at this, know that x is associated with children. So there's 200 children and 115 adults. All right. That's how we go about solving that problem. Now, by doing this practice with you, you're seeing a common trend of problem-solving strategies, what you're doing. All right. Now, I know that for the sake of this, okay, I'm going to do these next two, and then I'm going to leave the last one for you. Yes, I'm going to leave the last one for you because it's no sense. It's the same concept over and over again. Okay. So Jolene invests her savings to 2 bank accounts. One's paying 4% and the other's paying 11%. Simple interest. Okay. She puts twice as much in the lower yielding account because it is less risky. Her annual interest, her annual interest is $6,992. How much did she invest in each rate? So now we look at this, and we do have a situation where it says she puts twice as much in the lower yielding account because it is less risky. See, because we think about this in respects to, we have one a value and then we have another one, right? Now we have some value that's going to be put in both of these. One's paying 4%, so I'm going to go ahead and associate the one with the 4% with X, and then the other is paying 11%. So I'm going to go ahead and put 11%. And then it's going to go ahead and give her a total value of interest of $6,992. Okay. We know this equation is going to be one of the equations. Now, the thing is that we don't know how much she has put in. Okay. So she invests at each rate. Now, we know that this one is going to be equal to the value of this one, because they say to us that she puts twice as much money in the lower yielding account because it is less risky. Okay. So the thing is that we have, if it's twice as much that she puts in the lower, we can go ahead and put that X, which is declared at the lower one. All right. We can say that X is equal to twice as many as the higher one. All right. So because we think about this, the 4% is less riskier than the 11%. So that's why X is associated with is going to be double the amount of the Y. So now we have that declared. We can go ahead and substitute that in for here and go ahead and solve this. So we have this. Set up, and now we go ahead and just solve it. So we solve it. We're gonna take point 0.08, and then we have plus 11 y. This is going to be that. All right, and then this is nothing but legwork. I mean, again, it's going to be 0.19. I'm already tired of writing it all down because I'd be personally just putting it in my calculator anyway. So now it takes 6,992 divided by 0.19, and that'll be 36,800. So we have that is for Y. For solving for X, we're going to go ahead and double that value. So hit times 2, and we have X equals this. And so our X is our 4%, our Y is our 11%, and we have our answers. All right. Now take note that this is associated with this, okay? And this is associated with that. Just so you know why the 4% was associated with the 73,600. Now, we have how many milliliters of pure alcohol should be added to 200 milliliters of 12% alcohol solution to produce a solution that is 20%. Now, again, this rocks students a lot. They just, wow. So we're talking about pure alcohol at 200 milliliters. All right. We know we don't have the solution. We don't have the value of the number of milliliters collectively. So we just know that we have 200 milliliters. So we already know what the number of calories is for, or not calories, excuse me, but the milliliters is for the pure alcohol. So we have 200 milliliters, excuse me, 200 of pure alcohol plus some Y, and then we just don't know what that is. So we're going to call it out as X. Okay. The X is like the value of the solution. All right. So now we have that found. We're going to go ahead and say, now we have 200 milliliters. Okay. 200 milliliters of pure alcohol, which is going to be 1. Okay. That's its percentage is 1. Okay. Because it's pure alcohol plus, and then the 12% solution is what we're going to call out as the Y. So it's going to be 0.12 Y equals X. And we can go ahead and switch these letters around if we're not comfortable with it being the way I set it up. Okay. I could switch those letters. It doesn't make a difference. But now I'm declared 12% at Y, then I've got my setup. Now, oh, by the way, I'm sorry. This X, I don't have it done yet because it says 20% solution. So I need to multiply this by 0.2. That's 20% solution. Okay. So now that I have this finalized, I'll go ahead and have X. I can replace X into here, and I can solve for Y. All right. And then I go ahead and solve for X by plugging in that Y. So I go ahead and do that. So I'm going to go ahead and do 200 plus, and then I'm going to go ahead and see here. Oh, yeah, I'm going to plug in this for X. Okay. So I'm going to plug in this. And then I have this X equals 200 plus Y times the 0.2. And then this is nothing more than just me using the calculator again. I'm going to take 0.2 of 200, and then I'm going to take 0.2 of Y, and I'm going to isolate for Y. So I'm going to just use a calculator to do all that. All right, let me do that. So that's 40. That gives me 160. All right, and then that's going to be subtracting. So that's going to give me 0.8. And then I forgot the decimal point. I love that. Forgot to put the decimal point in there. All right. Now there we have that. Okay, so I went ahead and came up with the 20 milliliters. Okay, so we're going to go ahead and have that answer as what we need for the number of milliliters. So I know that these problems can be a little bit tricky, but they are what they are. But I'm going to leave that. I'm going to leave this lesson as it is. I gave you the meat and potatoes that's required for completing these questions. Okay, so go ahead and see what you can do with it.